Hey everyone, and welcome to today's episode of Frick Programming. Today we're going to go over the numeric data types. Now, numeric data types are very simple, so there's not going to be a coding section for this today. We're actually just going to go over our different types that we have. No code, so no need to get Eclipse up and running or your IDE up and running to test anything. These are mainly just a lesson, and everyone should know these, so we're just going to go over them really quickly. So as we get into it, our topics for today are the integer types, what are the different types for the integer types, when to use each type, and what the typical developer uses. And we'll do the same for the floating point types. So we'll just get straight into it. So first we're going to go over the integer types. And so the different types include the byte, short, int, and long. Now these all have their different ranges that they range up to, and they all have their different bits on that they carry themselves. So each one is a signed bit, meaning that it does go negative and it also goes positive. Unsigned bit number or unsigned bit integer would be a number that does not do negatives. Instead, it uses all bits to just do positive numbers. So as you can see, for each one of these, the range that they go to is more on the negative side than on the positive side. And the reason that we have to do that is that we have to include 0 on the positive side. So technically, for the byte, it does go to negative 128, but technically if we were starting at 1, it would also go to 128 on the positive side. But since we start at 0, we have to include 0. And I didn't include the range for long because it's such a big range that if you need to use a long or you're going higher than an integer, I mean, a long is the best you could do. You're gonna get there. You're gonna have that size. If you ever get past an integer in number that you need, which is currently sitting at 2.1 million, I mean, I think you may need a bigger thing. So, use a long. It should go into the billions, maybe even a trillion. The way to figure this out is actually may go even bigger than that. The way to figure out the range is to take this number, take the square of it, and multiply it by 2. And you'll get the next low range if you multiply that by -1 then. So it will be a pretty big number. So don't worry, if you do surpass an integer's top range or bottom range, you can easily just switch to a long. It is there for you. You're most likely not ever going to use it or need to use a long, but if you do, it's okay. So when to use each type, you will really only want to try to use the necessary type to store the number that you require. For example, if you only need a number from 1 to 10, use a byte. And if you only need a number that has a length of an array that can only have 1,000 items in it, you might want to use a short instead of using an integer or a long. If you use an integer or a long, you are using the extra bits in your storage, which if you're not using those to their full extent, or even close to their full extent, where something else smaller than it can still hold it, you might want to switch that to something smaller. So I know in all previous code that I've done so far, I've used an integer to just count 10 during loops. It's a typical thing that people use. And that brings us to what typical developers use. So when we use integers, we usually use the int. We don't care about using a byte, short, or a long. We only ever use a long if we need to use a long, which means we've surpassed integers range. But even that's rare. So we typically use an int. It's 32 bits. Which 4 bytes, it isn't too costly, but there is typically the cleanup phase of development. The cleanup phase only really comes at the near end of development. It could actually occur throughout all of development to make sure that you don't need to do a cleanup phase at the end. But the cleanup phase is typically you go back and you change all variable types to their lowest denomination. So in my for loops or in my looping, where I use an int to keep place where I am, and I know I'm never going to go above 32,768 or below that, I might switch that to a short. If I never go above 127 or below 128 or like below negative 128, I might switch it down to a byte. But there is an issue if you were to go over it. It does have overflow. So if you do overflow positive way, you will go negative. If you overflow negative, you will go positive. It's not something that you want to go through, and it's not something that we're really going to go over because if you're just doing this to learn the language, you typically use an int. So this brings us to our floating point types. The different types for our floating points are floats and doubles. And currently, you have both a negative range and a positive range. These ranges go into the accuracy of your decimal notation. So the float has a 32-bit IEEE 754 standard to it for the storage size. These are standards that IEEE comes up with, and every single year or couple of years, the standard could be rewritten or the standard could be updated. So this standard could be a little bit out of date from when I learned it, so just be on the lookout for that, but it shouldn't really change all too much for the storage size. The double has a much bigger range that you can go into. It does go into a plus 308 accuracy and a negative 324 accuracy on it. So it is highly accurate compared to a float. And when to use each of these types? Well, since double type is twice as big as a float, it is known as a double precision, while floats are single precision. And if you're looking for a high precision use a double, otherwise use floats. But the typical developer, we just use doubles. Floats require an F at the end of the line to indicate that it is a floating type. And if you forget that, it could cause errors because then it just goes into an integer or it doesn't compile depending on how your compiler works and catches errors. There's a lot of issues that floats can cause that you don't typically pick up on really quickly. So we all just use doubles. It's much easier and it has higher precision. So if we ever need that higher precision, we have it available to us. It is taking up a bit more storage, but it is there available to us to use. And with that, that concludes our lesson for today. I thank you very much for watching. I hope you guys enjoy yourselves and come back on Thursday for the next lesson. Thank you very much.